Okay, review. What's on the test? So for this unit, we're not actually going to have a test. So no test. What we're going to do is we're just going to do another assignment. So we're going to have an assignment to finish this off. We already had one assignment earlier in the unit, and we're going to have one more. If you didn't get the assignment done, it was the making a picture. If you didn't like your picture because you don't think it's going to get a good mark, what you're using is Desmos to create a picture. Okay, it was the last thing we did before the break. So what you need to know about this unit, however, is the Cartesian plane. Okay, so that's very important. You need to know what quadrants are. So what's a quadrant? You need to know the axis. So both the axes, the origin. What is a coordinate point? What is the origins point? Coordinate point. What's the origins point? Things like that. Okay, correlations. You should know, I'll switch colors here. You should know positive, negative. You should know weak, or I guess positive, negative, we'll say linear and non-linear. Line of best fit. You should be able to say whether, I guess up here, positive and negative. So we already said positive and negative, excuse me. So strong or weak. And then line of best fit, you should be able to draw one. Distance time graphs, we just went over that. You should be able to label a distance time graph. Now, what I mean by label a distance time graph, this is something that people struggle with. Okay, so describe a scenario that could represent the following graph. Okay, so if I zoom in, this says distance from the school. So I need to be exact. So what I'm going to do, just for argument's sake, I'm going to label each of these little sections, and I'm going to have something about each section. Okay, I know at the end, my distance from the school is actually 0. So I've gotten back to the school. Okay, here, my distance from the school is 3 kilometers. Okay, so what I could say is for section 1, you could say something like, I left home to go to school. Okay, so I left home to go to school. I was going pretty fast, but if you notice, I was actually going almost just as fast on the way back. So part 2, I got a phone call from Bob. So my friend Bob called. Part 3, I went to Bob's house. Went away from school to Bob's. I guess in part 2, what I need to put is I stopped, because I stopped right in part 2. Part 4, stopped at Bob's. Because I've stopped again. I'm not moving in part 4. Okay, you could put the times in here. I'm not overly picky about that, but I do need to see that you know what's going on. And then finally, Bob and I ran to school. You can notice that last line's the steepest. We were late for school. Bob and I ran to Mr. Shaw's math class. Okay, I've got a situation for it. A lot of people struggle with that. Okay, how long did it take for the student to get to school? Well, we need to look at the total time. The total time was from 0 all the way to the end, which if each of these dashes is 10 minutes, that's 115 minutes. How many kilometers did they travel? This is a tough one, because what we have to recognize is in section 1, So I'll write them all out again. In section 1, we traveled 1 kilometer. We went from 3 down to 2. In section 2, we went 0 kilometers. We didn't move. In section 3, we went from 1, 2, 3. We went 3 kilometers. In section 4, we went 0 kilometers again. In section 5, we went 5 kilometers. So in total, we went 1 plus 0 plus 3 plus 0 plus 5. So we went 9 kilometers in total. Okay, you need to look at the whole picture. What's happening in the flat parts? Okay, we've already talked about this. We're stopped. Okay, now it says calculate the speed of each section. So I'm not going to go ahead and do this, or I'm not going to give you the actual speed. What I'm going to do is I'm going to just give you it as a fraction. Okay, and I want you to practice reducing your fractions, but what we're going to have is, we know the first section, so I just have to erase a little bit off of here. So it's getting a little messy. So the first section, there we go. We've got 1, 2, 3, 4, 5. We know in sections 2 and 4 we've stopped, so that's 0. What are we doing? Kilometers per minute, or our units. Okay, I'm getting my units from the y over x. Okay, so in section 1, we've moved 1 kilometer over, we've gone to here, which would be 15 minutes. Okay, so 1 kilometer per 15 minutes. You would just do 1 divided by 15 to figure out what the speed is. In number 3, we're doing the same thing. We've moved 1, 2, 3 kilometers. Now this one's a little bit harder to find out how far we've gone. We started at 25 minutes and we ended at 55 minutes. So 25 minus 55 is 30 minutes. Now, 55 minus 25. Part 5, we're going 5 kilometers from the top all the way down. 5 kilometers. And it's taken us, we've moved from 75 all the way to 115. That's going to be 30 minutes again. And you can see right there that that's a faster time. Okay? So, we've calculated our speed, and you would divide those all out to calculate the actual speed. For each scenario, describe the relationship of the variables. So what we're looking at here is dependent and independent. So we've got the amount of fuel in a rocket ship and the distance from the Earth. Well, the distance depends on the amount of fuel. So the amount of fuel is independent and the distance is dependent. The amount of money you have and the size of your shoe. Now, a lot of people wouldn't really understand this one, but if I have a size shoe of 0 or a kid's size 1 or 2, I probably don't have any money because I'm probably a baby. So the amount of money you have typically, now it stops eventually, but typically depends on the size of your shoe. Because your shoe gets bigger as you get older. The size of your annual salary and the number of university degrees you have. Now again, this isn't always true, but typically your annual salary depends on your schooling. Okay, now that's not always true, but it is true a lot. Okay? For each relationship, draw a scatter plot. So this is nonlinear, strong, and negative. Well, nonlinear means it's not a straight line. Strong means all the points are pretty close to each other. And negative means it's going down to the left. Down to the right. So what I could do is just something like this. Okay, I'm putting a whole bunch of dots close together. They're flat, and then they're kind of curving down. Okay, weak, positive, linear. Okay, dots are kind of close together. They're following a pattern. Positive is going up to the right, and linear means it's a line. So it's going to be something like this. Okay, they're kind of close. There's a few that aren't right on there, but it does follow a trend. And then no correlation is just random dots, kind of all over the place. There's no pattern whatsoever. Okay, so this last one, how old is a baby that's 45 centimeters tall? So if I'm looking at this, the first thing that I need to recognize is I need to put a line of best fit in. Okay, so if I'm drawing this, what we have here, so I've already gone ahead and drawn one, the biggest mistake people make is that. Okay, they start their line of best fit at 0, 0. Now, a line of best fit it can start at 0, but it doesn't have to. So for this one, the line of best fit is probably somewhere in there. Okay, I've got just about as many on top as I do on the bottom. The ones on the top are a little further away, but you could say the ones on the bottom, there's a couple more. So that's probably my line of best fit. So now I'm going to use that line, and remember the term interpolate. Okay, I'm going to interpolate this data because it's inside the data. I'm going to say, how old is the baby at 45 centimeters? Well, I'm going to draw a line over, and then I'm going to draw a line down. So then 10 months. Okay, the next thing says, how tall are they at 20 months? Well, I'm going to extrapolate. I'm going to be outside of the data. I'm going to go all the way up to the line, and then I'm going to draw a line over. So here we would say between, 68 or 67 or 69. So it says 65 to 70. I would say probably 68. It's closer to the top centimeters. Okay, I would accept 67 as well. All right, and that is kind of all the stuff we've done. You're going to work on an assignment after.